So my name is Philip, and I'm going to be talking about the rise and fall of end-to-end testing at scale. So the main question that I want to explore today is, how do you test inter-service interactions in a scalable manner? And in particular, scaling to many engineers and many services, right? And I'm going to explore this question in the context of Nubank. This is sort of an experience report of what we've been doing over the last few years. I'm definitely not an expert in this. It's more just like observing what my colleagues have come up against, and I was for like 2 months on the team working to solve this problem. So I had a short stint with them, but then went on to other things. So what is Nubank? Nubank is a Brazilian fintech built around the idea of improving the banking experience for Brazilians in general. There's a bunch of big banks monopolizing the market there, and so we're there to sort of help the users. We're powered almost exclusively by Clojure and Datomic, so we have about 200 microservices powered in Clojure at the moment, with about 250 engineers working on those services. And what are we testing at Nubank? Well, in general, all of our services adhere to this hexagonal microservice architecture, which is also called ports and adapters. And the general idea behind this is that you have in your core, at the middle of the service, data models and pure logic. And then this is going to be, you're going to interface with the outside world via several other layers. So the controller layer is going to take that core data model and logic stuff and talk to the I/O layer, which is the ports, so things like Kafka, HTTP, and Datomic. But it's going to have to translate the data models into what's expected over the wire via the adapters layer. And then how are we going to test this? So I think earlier you guys saw another pyramid very similar like this, with at the bottom unit tests, which are the things that are fastest to write and interact with, and at the top some sort of Interservice or e2e framework. And so to go over briefly what these layers look like, and then I'll jump into the top layer, which is the focus of this talk. So at the unit test layer, you're really focused about one tier of the hexagonal architecture, or specifically one function, testing the behavior of that function. And so you can mock things at other layers. Maybe you don't have things to find, you're doing TDD, so you can make use of mocking and stubbing and whatnot to do what you need. Then the next layer up is at the single service level, and you only have mocking at the ports level, so when you're doing I/O with the outside world. And the rest of the service is unmocked, so any tests you write are going to get coverage over the entire service. And what's nice about this is that you can send HTTP calls or send messages, Kafka messages to the service, and it's going to activate some business flow inside of the service, and then you can test the state of the service afterwards. So it's very much like testing at the boundaries. You're looking at the service from the outside and sending it things and seeing the results, but you don't really poke on the inside. So you can get really, as I said, nice coverage with this. And then the last level is inter-service testing, which has different various approaches that give you different types of coverage. So what do these look like? You have testing in prod, you have schema compatibility, ConsumerDriven Contracts, and end-to-end tests. So one of them, testing in prod, which is this idea of not having inter-service tests, is that you rely more on monitoring and your deploy infrastructure to be able to roll back mistakes when you deploy them. And this is embracing the fact that no matter how good your tests are, you are going to deploy mistakes, so you might as well get really good at just rolling things back, making sure that you detect them really quickly. Another approach is schema compatibility checks, where say you want to deploy this blue service, which is the one on the far right, and it talks to these other two services, but you don't actually assert anything over the business logic in any of the services. You really just check if the data passing between them is in a form where everyone understands everybody. So to deploy the blue service, all you check is the data formats of the incoming and outgoing messages coming from other services. And then if you want to solidify that and get coverage over not only the formats going in between services, but actual business logic inside of them, you have end-to-end tests. And so this is, you might have a test suite, which is some sort of client that sends HTTP calls to any of these services to activate business flows. So for instance, you could say, create me a new user and make some transactions in their account. And then once that's done, you can say, try and close a bill and assert that like the bill has these transactions in it. And so it's this client sitting off on the side, hitting the system, making these requests, interacting with it, and then checking, okay, does the bill look like what I expected it to look like? So this gives you coverage over the whole system. And then an approximation of that is the idea of consumer-driven contracts, where instead of having, say you're trying to deploy that service on the right, the blue guy, and you want to test that it can still interact with all the other guys, instead of talking to them directly, you go through a proxy, this like consumer broker, which represents what the other services expect from you and what you expect from them. And so to deploy your test suite, you don't have to like spin up all of the services, you just have your service and the proxy. And so it gives you similar coverage to end-to-end tests, but since you're doing an approximation, you don't get certain things like with distributed architectures of eventual consistency and timing issues and whatnot that you might get with an end-to-end setup. So with Nubank, we started in 2013, so about 5 years ago. And for some reason, I wasn't there, but we decided to use end-to-end tests to get the coverage at the Interservice level. And I think this was very important for us because we have a super complicated domain, which is like credit card and financial stuff, and we're using distributed services. So it's like complexity on top of complexity, right? And the end-to-end test suite gave us the ability to make really fine-grained assertions over the complete system, so you could cover really complex business flows. So it gave us a lot of confidence when we're starting out and trying to figure out our system architecture. And back in the day, there were only a couple of services, so you could run all of this locally. You spin up a couple of services, run your end-to-end tests on your machine, or you could have a little remote cluster that you could connect to with a REPL and iterate on. But of course, whenever you deploy a service, it's gonna go through this e2e test suite on the CI pipeline. So once you get the e2e test nailed down, it's gonna be running on every deploy. But since it is kind of heavy, it takes about 15 minutes or so. We were only testing happy paths, and but with this, we were able to catch nice issues with our distributed architecture because you were actually taking a copy of the prod stack and putting it in a test setup, or like sort of like a staging setup, and running through actual flows, exercising things like if you produce a bunch of Kafka messages, they will eventually all get processed and like close bills and whatnot. Cool. But we grew, and so we have a bunch more services, we have a bunch more engineers. Somewhere along the way, we sort of lost the tradition of testing things locally, probably just because it's actually really hard to spin up a couple of instances on your laptop and get them running. There's always things breaking and changing and whatever. Also, these tests were not very fun to write. Turns out that like making sure you can write a reproducible test that's not flaky over and over on a system that's not on your machine is really annoying. So everybody sort of hated interacting with the system. And it was also the main like bottleneck to deploy. Because if you deploy if you make a change in your service, and then you have to wait 15 minutes, but everybody is doing this at the same time, when there's like 200 engineers, we had like backups at like peak work hours of like 2 or 3 hours at best. So like people were showing up really early in the day just to deploy their changes. By really early, I mean like 10 a.m. And then like everybody else comes in at 11, and then you're just like screwed for the rest of the day. But yeah, it was really annoying. And so you're waiting those 2 hours, and then your test or your changes don't get deployed because there's some flakiness in the system. Because it's a distributed system, of course, like you're gonna have retries and timing things, but things will also just fail, and it's really hard to write these tests robustly. And we only saw it getting worse. So we had ideas of like how to fix it, how to make it a little bit more scalable, but as you add more people, more machines, it's still gonna hit these scaling issues. So at that point, so about four years after we started using e2e, in 2017, we decided to ask ourselves, is it worth it anymore? I mean, we definitely got some value from it in the beginning, but it's taking forever for anyone to deploy work, and it's because of e2e. So we went and we looked at what were the failing tests that e2e was having, right? And so there was flakiness, we rolled out flakiness, and then what was left is unexpectedly just people changing the behavior of their service and forgetting that they had e2e tests that asserted a different behavior. And so almost all of the test failures were this case. It was just like you're deploying some change that's expected, you covered it with your unit and integration tests, but you forgot about the e2e test because there was a large distance from your normal work to that test suite. And so this was causing the change, the breakage. And when you ruled those out, we had like only a bug or two being caught every couple of weeks with e2e. So it turns out that, like, I don't know how it was in the beginning because we never like looked at if we were catching bugs in the beginning, I think, and I wasn't around. But by 2017, like e2e wasn't actually catching any bugs for us. So we decided to move on. And where do you go from there? So there's several other options there. And we wanted to explore the space of this, right? So if we looked at testing in prod, unfortunately in 2017, our like deploy setup wasn't super mature. We were on CloudFormation, so it took like 30 minutes to actually like deploy a new change because you had to spin up new instances and whatnot. We didn't have really good canary deploys or rollbacks and whatever. So testing in prod wasn't an option. Now that stuff's better. We have Kubernetes, we have canary deploys, all that good stuff, but a year ago it wasn't that way. So the next logical thing to get really nice coverage of like complex business flows and whatnot, if you're not doing e2e, is consumer-driven contracts. Because you're still running like assertions over business flows, like your tests are triggering logic inside of your service that you're trying to deploy, but then the contract broker acts as an interface between like your service that you're trying to deploy and other services and says, okay, if you give me this data, like the other services are expecting it to have this other form, and so the test breaks and vice versa. So we tried building a prototype of this. Actually, some of my colleagues did when I was on this team working on this project, but I didn't get into it because I didn't really understand CDC. I still don't really understand consumer-driven contracts, which is why I'm not really explaining it in depth here. If someone actually uses this stuff, like, and it works well for them, I'd be really curious to hear how, because when we were looking into this, we like saw these people talking about it, and they're like, yeah, it's amazing. And then we like tried to figure out how to actually use it, and we couldn't. I mean, maybe my teammates did a better job than me. But anyways, they built a prototype and worked with another team to try and migrate them away from the e2e tests that they had onto this consumer-driven contracts approach. And what they found was that they were able to get coverage and like write nice assertions and whatever, but the upkeep and sort of the wiring up, the initial investment was really high, because it's really like, you have to say, okay, when your service produces this type of data, it's gonna like then connect to this other one, and you have to like set the contracts in the first place, which is a very tedious process. And so when you're talking about getting like 250 engineers to adopt some new setup with like hundreds of services, it's a slow migration. And we weren't even sure if it would pay off in the end, in the sense of like, are we going to be able to build abstractions to make the maintenance of this CDC setup less annoying and tedious. So we decided to go with something a bit more lightweight, which was the idea of schema compatibility checks. And this fits particularly well because it turns out that we weren't actually like deploying many bugs, or e2e wasn't catching many bugs, which either means that the test coverage of e2e wasn't good, or it just means that layers below were doing a good job. So if we go with the idea that layers below are doing a good job, then we don't actually need like really comprehensive assertions at this inter-service interaction level. So the idea of just checking if they can still talk to each other fits well. So what does this look like? So we wanted a tool that would say, would answer two questions, which is, okay, if I change the data format of some data that I'm producing, do downstream consumers break when they try and read it? Another question is, if I'm trying to consume some upstream data and I decide to change the format that I expect, can I still consume that data? Which is a question that can be answered statically if you're using really simple schemas. So I think like Avro format or protocol buffs, since they don't have really like complicated, like they don't have much expressiveness, you can actually computationally determine if two schemas are compatible. But we're using Somatic Schema, which is like similar to Clojure spec, where you can insert arbitrary function or predicates inside of your schema, right? So if you want to determine schema compatibility when you have arbitrary functions, that's equivalent to determining the equality of two functions, which is a computationally impossible problem. So to deal with this, we went with the idea of approximating it by generating examples of data that satisfies these schemas. So with this, we built a little system, a lightweight testing tool called Sashan, which the idea behind it is that you have a microservice that's going to produce data and consume data. And for us, that's mainly, currently we were most concerned about HTTP endpoints, HTTP and Kafka. Obviously, you could do things like storing files on S3, or if you're like trying to serve data sets and whatever. But this is the main way that we communicate between services. So that's the main thing we're concerned about. So we want to annotate all these consumers and producers with schemas, which we generally already have, because but we just need it in a way that's like easy to find them and know exactly what they are. But given the fact that all our services are essentially the same like flavor of structure using components, it wasn't too hard. And then the idea is that when you do this and you want to deploy a change to your service, what you're going to do is generate a bunch of examples of data that satisfy the schemas associated with what the service is producing, store those somewhere where other services can find those examples, but then also download examples from other producers that you want to consume from, and make sure that you can use your schemas to coerce those examples. So it's a fairly simple idea, but it actually works quite well. So with that, I want to go into what this looks like with code. So let's jump into some little example microservice called Newton, and we're in the producer namespace of this microservice, right? And so at the bottom, you'll see that we have the topics map, which is defining what topics you produce, and the schema that they use. And so here we're producing a topic called material, using the material schema, which has these four entries, which are like element, type, class, and weight. And they're defined in a prismatic schema format. So here you'll see element has type string, weight has type integer, and then these other two, type has type material type, which is an enum of several different options of keywords, and then class is like a schema that uses a arbitrary Clojure function as a predicate to say, okay, it's going to be an integer, it's constrained to be an integer, but it has to satisfy this like random assertion that I made up or found on the internet, which is that the number is pronic, which I don't really know what it means, but there's some deterministic way of figuring out what pronic numbers are. So when you run Sashan on this microservice, it's going to spin up the system, spin up the whole microservice, find all the components that are registered as producers that satisfy a particular protocol, and then generate a bunch of examples for the things they produce to. So when we do this, you can see client run Sashan, generate a bunch of examples, and it finds material, and it tries to generate examples, but it runs into an issue and it says, okay, we weren't able to generate a bunch of this stuff. Sort of cryptic message, but what it means is that it tried to generate examples that satisfy this material schema, but it couldn't. And the reason for that is that when we have this constrained schema, it's going to just guess a bunch of numbers, and it doesn't know how to guess pronic numbers. So what we have to do is we have to actually change it to this, which is, it's still constrained, but we attach a generator to it, which is just a fancy way of saying when you wanted generate an example of it, use this formula that takes in an integer and creates a pronic number out of it. So when you do that, then it works. And what you can see here is, we're mostly concerned about this one. This is like a HTTP endpoint that we define. But here we have the endpoint material, and we have inside of message a bunch of examples of material messages. So you'll see like that pronic number, you have like class 0, 2, and 20 and whatnot. And then on the consumer side, so now we go to my other service, which is called the lymbic. So we have Newton sending materials to lymbic. And in here you have topic settings, consuming from the topic material with the schema material. And you'll notice here that I defined my own different material schema, which only has 3 elements, or 3 keys in it, which are element, type, and weight, because we don't care about the class guy. And so what happens when we try and verify that like a lymbic can talk to Newton and consume things that messages on the topic material with this form, is we get this thing saying, okay, when you do a run Sashan check using the examples Eden file, we are validating the endpoint material, and we have this error where there's a disallowed key called class. And then there's an example of it. And the reason for this is that you said, oh, I only want these 3 guys, but there's a 4th thing. So this is where we have to actually make use of this idea called tolerant readers in industry, which is the idea that your producer should be strict, but your readers should always be really like tolerant or flexible, and you define what you need in the reader, and then you can also just have a bunch of random stuff that you don't really care about. And so when you do something like this, where you say, okay, the keyword, if it's a keyword that's not any of these 3, then it can just be any. When we run this, down here you see, okay, we were able to verify that the examples on the material topic were all consumable. Let's see. Cool. So after a year of using the system, this hybrid of having like unit, single service integration tests, and just a lighter layer of schema validation checks, we're able to get the so Sashan runs in about 5 minutes. And the reason for this taking so long is that you have to actually spin up the microservice in a test system to find all the endpoints that it consumes and produces to. We could maybe do this statically or something, but the easiest way is just to spin it up and then find, traverse the system and find them. But with that, these test suites are localized just to the service, so you can, and it has to has to find all the other examples from the other services they've generated, but it runs in sync with, or in parallel with unit and integration tests, so the whole build takes much less time. You can deploy something in 15 minutes or so instead of a couple of hours. Another cool thing with this is that we used to have this centralized schema code base where all the microservices that used, that had to talk to each other would use schemas in this code base. They're all centralized. And so whenever you made a change, you had to bump this schema in that code base, bump the version, then bump all the consumers and producers. And so it was this huge churn of code that was just unnecessary because it was literally just to get everybody in sync. With this, you can decentralize all of it and have it all coordinated via this generative example testing thing. Which also means that we were forced to write schemas that are generative, which unlock the ability to start doing much more generative testing, which we didn't do as much of before, because we would try and generate examples, but we didn't have good generators associated to our schemas, so it wasn't really working out. We still do have a couple of teams on e2e, and the reason for that is that they're like core credit card like finance teams that have really complicated flows, and they're just like still sort of afraid to move off of this. And the other one is, another team is the authorizer team that has to like, it's hard to explain. We have like a bare metal authorization deployment, and then we have our like normal stack that's in the cloud, and they have services that like communicate between these two, and so any small change in Kafka or whatnot will like have really horrible effects to our business. So something like e2e is like the best way to test that, because it's the real environment, but just running tests over there. And so with that, we like had successes killing e2e in a sense, but of course there were uses where e2e was very helpful, which was when you're introducing a new flow or like a new service or something into the mix. You sort of need to iterate on how it talks to the other services and whatnot. The easiest way to do that is with something like e2e or with a better staging environment. So we're still lacking some tools where e2e was helping us, but I think they could be replaced with a toolbox of lighter weight tools. And so, for instance, some teams inside of Nubank are playing around with some ideas of how to do this, or various tools of inter-service testing. One that I just heard about a couple weeks ago that a team is trying, which I thought sounded really cool and crazy, is the idea of testing as a monolith, but deploying as a microservice. I don't know if this is like common, but I had never really heard of it. Where the idea is that your team has a bunch of microservices that they control, and they can bump them all to the same version, like library versions, which means that you can run them all in the same JVM. And then if they're on the same JVM, you spin them up locally, and instead of doing I/O like through the network and whatever, you just replace those with function calls. So they're playing around with this. I hear that it's making progress, but I don't know how it will pan out. But I thought that was a cool idea. Another one is this idea made by a couple of interns at Nubank called the Macario, where you're able to like spin up a couple of microservices in a hybrid like local and cluster setup, where if you want to iterate on making changes to the service you're working on, you have it locally, but it needs to talk to other services, and you can't run those all on your machine, so you do it with Kubernetes. Also something that's really early that I don't know how it will pan out. So with that, unfortunately, we haven't been able to open source Sashan, just because it's really specific to our setup. But the ideas are fairly approachable, I think, so I would imagine that anybody could roll their own. But if you're interested in what our e2e tests look like, which I didn't go super into detail on, there's a code base called Salvage, which is more for a single service integration test, but we actually share the same like setup for our e2e tests, so they can be used interchangeably. And with that, if you have questions, find me at Phillip Mates, and if any of this sounded super interesting, we have positions in Berlin and São Paulo, so let us know. Thanks.
So the third part is actually open source in Sashan in your trilogy.
Maybe.
Okay.
I mean, I hope that doesn't need to become another talk. I feel like maybe I can talk about something that's not testing next year. We'll see.
Cool. So any questions, please? Yeah.
Thank you for your talk. Very interesting. I was wondering, what if the producer and the consumer share the same schema? Do you now duplicate the schema, or is it like not dry, so to speak?
It's up to you. I think that's something we're not, like, it's sort of still unclear at, like what the best practice is. I think the idea would be that you duplicate it with the idea, with like the intention that maybe they diverge. Maybe, so for instance, maybe your producer is going to be consumed by many different consumers, and so you don't want to couple them. But yeah, I mean, it can get ugly with that.
One more there.
I was wondering, what kind of are you using like JSON messages in your Kafka messages, or do you have a schema such as like Parquet or other formats?
No, I think we just use Eden or JSON. Yeah.
Any other questions?
Thanks. So if you were to say, let's say you need to rebuild one of these microservices,
Mhm.
how do these tests help you with that?
Yeah, I think like there's definitely a hole now in terms of like getting coverage of the whole system. The observation that we made where we weren't actually catching very many bugs, so we don't need this huge system like going all the time. But I didn't get into detail about how, okay, when you're like adding a new service, you do need to test how it interacts with other services, and like e2e was really helpful for that. But once it stabilizes, I think the amount of coverage that we're able to get from just your single service integration tests are sufficient. Like there is the ability to, because when you do single service integration tests, you define the data you're passing to your service, right? So if you make a mistake with that, your test isn't comprehensive. Or if the behavior changes from what the other service is like producing and you don't remember, then like your test isn't reflective of reality, it's out of date. So there is that mismatch, right, between services, and that's where consumer-driven contracts, I think, is supposed to force you to update them, because your services, if you change them and they break the contracts, it's like you have to go and update the tests and the downstream guys. But one thing about this Sashan approach is when you do have schema breakages, like you produce something that the consumer isn't expecting or it changes a format, that's indicative of the fact that your behavior has changed, and you need to go and like think twice about if these things line up. So it's definitely not as powerful as e2e. There's still like issues, but at least we can move much faster than before.
Any final question? Okay, thanks a lot, Philip, again.
Yeah.